Hello, my name is Sophia, and today I'm going to be talking about my old molecule and wrapping up some conclusions about Xanax, and then I'm also going to be talking about new properties with the molecule Rifampin. So firstly, some of the properties that were found about Xanax was that it had strong intermolecular forces like hydrogen bonding. It was found to have a high melting point / boiling point, and it was also found to be a very polar molecule, which means that it is more soluble in water. So for these properties, these help the molecule Xanax be administered the way that it is via pill form more easily, because the strong intermolecular forces and the high melting point / boiling point allow the molecule to stay in its solid form without just breaking apart. And because it was a very polar molecule, this means that it was very soluble in water. And this is good because most people who take Xanax take it in pill form, and they usually have it with a glass of water and swallow it. And so since that is very easily to be dissolved in water, that's also good because when they ingest the pill, then it will be able to release its chemicals and go throughout the body to help do its main job of releasing anxiety and tension. So now with this next molecule, rifampin, the first thing is, why did I choose this molecule? So I chose this molecule because it was one of the medications that I had to take when I had tuberculosis. And so with this molecule, it is usually in a medication pill form, and it's usually given to patients who either have active TB and late TB. And what the pill does is it helps fight off the microbacterial organisms that are found within the lungs where TB targets the most. And so the next thing we're going to be talking about now is the functional groups. So rifampin overall is a very, very big molecule. So I'm going to break down the functional group. So here is an alcohol, here is an alcohol, here is an alcohol, here is an alcohol, and here is an alcohol. Right here, this is an amide. And then there's 3 amines. And then this is a carbonyl carbon. And then this is an ether. This is an ether. This is an ether. This is an ester, which it's a pretty big functional group, as you can see right there. And then this ring right here is an aromatic ring. And so next, polarity. So because rifampin has 43 carbons within it, and it has overall it has 15 functional groups, but only 14 of those 15 functional groups are polar, either containing oxygen or nitrogen. So when you do the math, 43 divided by 14, 43 carbons divided by 14 polar functional groups, this will give you a ratio of 3.07. And because this ratio, it's a very accepted ratio. So that means that this molecule overall is going to be polar. And because it's a polar molecule, that means that it's going to be able to dissolve in water, because like dissolve like dissolve likes, and water is a very polar molecule. So it's going to be able to easily dissolve in water. And so some expected forces in rifampin are strong hydrogen bonds, and we know this because there's a lot of OH groups, right, all over. And for hydrogen bonding, you can either bond to F, O, or N. And then another expected intermolecular force is dispersion forces. And you can see it all throughout the aromatic ring here and this ring next to it with the carbon and hydrogen bonds. And another place you can see it is along this chain here. There's going to be lots of dispersion forces with carbons and hydrogens there. And because it has those 2 intermolecular forces, that means that it's going to probably have a high boiling and melting point. And then the last property is acidic or basic, both or neither. So we can predict that this molecule is probably going to be basic because it contains 3 amines, which is found within covalent bases. It doesn't have any carboxylic acid functional groups, which is mainly found in acids, so it is definitely not acidic. and it can't be neither because of the three amine groups, but I wouldn't suggest that this is probably a very strong base either. And then that's a wrap on all of the molecular diaries in the final entry of week 5.